Hey, Anthony Carruthers, Better Lesson Master Teacher Project. And in this screencast, I'll be talking about how I stop at key points in the lesson to make sure students are understanding. In this particular activity, we're discussing the geometric mean. And at this point in the activity, we've talked about geometric sequences. So we've talked about how geometric sequences have a common ratio. Here's an example of a geometric sequence: 4, 12, 36, and 108. And I really want students to understand this here. So any two successive terms that you pick in the sequence, for example, 4 and 12, if we take the second number 12 divided by the first, we get a ratio, which in this case is 3. And then if we take the next two successive terms, like 12 and 36, again, the second number, 36, divided by the first number, 12, we get 3. And so forth. So also 108 divided by 36 is 3. So just driving home the point that you have a common ratio in a geometric sequence. Okay, the next step that we have to take is to show how 12, because it is situated between 4 and 36 in the geometric sequence, is the geometric mean of 4 and 36. So 12 is the geometric mean of 4 and 36. Likewise, 36 is the geometric mean of 12 and 108 for the same reason. So I just spent some time making sure that students really get that with numbers, because later we're going to look at a more abstract example, and I want to make sure that they have a concrete foundation first. So here is that abstract example. We have a geometric sequence A, X, and B. And from what we learned in the previous example, that would mean that X is the geometric mean of A and B. So now we want to talk about what happens as a result of X being the geometric mean of A and B. Well, what we know about geometric sequences is that X divided by A is some ratio R, which we've denoted here. And we know that B over X then would have to be that exact same ratio R. So that leads us to equation 1. X over A is equal to B over X. So I would stop and have students pair share on why equation 1 is true. And hopefully they will be able to say something like, since X over A is equal to R and B over X is also equal to R, then X over A and B over X must equal each other, either by a transitive property or a substitution. And likewise, I would ask why equation 2 is true, and hopefully based on equation 1, they would say, according to the means extremes property, equation 2 is true. And for equation 3, hopefully students could find out that we've just taken the square root of both sides. So again, there's just some things here in the handout that I don't want students to gloss over, so I just spend some extra time going over them to make sure they're actually getting the key understandings out of it.